Welcome to the DIY Honda Garage channel. The DTC codes P219A and P219B specifically indicate an air-fuel ratio variation for cylinders in a Honda Pilot manufactured between 2016 and 2022. DTC P219A pertains to Bank 1, which typically contains cylinders number 1, 2, and 3, while DTC P219B refers to Bank 2, usually encompassing cylinders number 4, 5, and 6. An air-fuel ratio variation means there is an inconsistency in the balance of air and fuel entering the combustion chamber, which can lead to performance issues and increased emissions. This fault may require addressing multiple vehicle components, including oxygen sensors, AF sensors, and fuel injectors, to restore proper engine function. Ensuring the complete diagnosis of both codes and related DTCs is imperative before further troubleshooting, as codes can be interconnected. Additionally, reviewing the vehicle's onboard diagnostic system, OBD, data will provide crucial insight regarding the state of the cylinders and related components. DTC P219A indicates an issue specifically with the air-fuel ratio variation in Bank 1, while DTC P219B highlights the same variation for Bank 2. The vital components involved in these discrepancies include the AF sensors and the fuel injectors. The AF sensors, located in the exhaust system before the catalytic converter, are responsible for measuring the oxygen content in the exhaust gases, which informs the engine control unit, ECU, about the optimal air-fuel mixture. Any malfunction or degradation in these sensors can substantially impact engine performance and efficiency. Additionally, each cylinder has its fuel injector, which supplies fuel to the engine. Located on the intake manifold side, these injectors must operate smoothly to maintain the correct air-fuel ratio. Therefore, assessing the performance of these components is essential when troubleshooting DTC P219A and P219B. Several factors could lead to the triggering of DTC P219A and P219B. One leading cause is faulty AF sensors, which can misread the oxygen levels and throw off the air-fuel mixture. Additionally, clogged or malfunctioning fuel injectors may hinder the precise delivery of fuel, further compounding the issue. Another significant factor encompasses engine compression problems, where one or more cylinders may not be achieving the appropriate compression levels, affecting overall performance and emissions. Mechanical issues, including valve clearance, misadjustments, or intake and exhaust blockage, could also be contributing factors and should be inspected accordingly. By understanding these potential causes, technicians can streamline the diagnostic process, focusing first on the most likely culprits reported in the trouble codes. Several symptoms may indicate the presence of DTC P219A or P219B in a Honda Pilot. Firstly, poor engine performance is a common sign where the vehicle struggles to accelerate adequately or operates sluggishly. Increased fuel consumption is often observed, as these air-fuel discrepancies may lead to a rich or lean mixture, driving the engine to use more fuel than necessary. The emissions warning light on the dashboard can illuminate due to these irregularities in the air-fuel ratio, signaling potential environmental and regulatory non-compliance. Rough idle is another symptom, whereby the engine might sputter or shake during idle conditions, resulting from an imbalance in air and fuel delivery. Recognizing these symptoms aids in early detection and can lead to prompt remedial measures. The first step in troubleshooting DTC P219A and P219B is problem verification through the Honda Diagnostic System, HDS. Begin by turning the vehicle to the on mode without starting the engine. It is critical at this stage to record various parameters such as vehicle speed, engine speed, manifold absolute pressure, MAP sensor readings, engine coolant temperature, ECT, accelerator pedal position, APP, and short-term fuel trim values for both Bank 1 and Bank 2. After recording these parameters, start the engine and hold the engine speed at approximately 3,000 RPM, ensuring that it is in park or neutral while there is no load. This step will help the engine reach working temperatures, signaling the coolant fan to activate. Following this, execute the cylinder AF test 3 times through the inspection menu on HDS, assessing whether the results indicate the system is operating correctly. OK. If it indicates issues, proceed to the next steps in troubleshooting. Step 2 involves conducting an OBD status check to confirm any failures linked to DTC P219A and P219B. Begin by test driving the vehicle under the parameters recorded in the previous step, specifically keeping an eye on the same readings for vehicle speed, engine speed, map sensor, ECT, APP, and fuel trim values. Throughout the drive, utilize the HDS to monitor the OBD status, specifically checking the DTC menu for indications of P219A and/or P219B. If the HDS reflects a failed status for either code, this reiterates the presence of a confirmed failure that needs addressing. However, should the HDS indicate a past status, it may suggest that the system is functioning abnormally, sometimes intermittent failure. In that case, you'd want to observe whether any freeze data or onboard snapshots reflecting the DTCs are available for further diagnosis. The third troubleshooting step focuses on performing an engine compression check, vital for ensuring all cylinders are functioning effectively. Begin by turning the vehicle to the off position and preparing to carry out a cylinder compression test. This test identifies any cylinder with lower compression compared to its counterparts, which could indicate mechanical failure, like a blown head gasket, a worn piston ring, or valve issues. If the test reveals discrepancies, it is essential to address the underlying compression problems before proceeding. Repairs might involve servicing the engine components to restore normal function. Should the compression results be satisfactory across the cylinders, then you can move to the next diagnostic step in the sequence. Once engine compression has been verified, the next critical step is to check the valve clearance. Valve clearance is crucial for the engine's overall operation, ensuring that the valves open and close at the necessary timings. In this step, you will inspect the valve clearance around the engine to compare it against specified values according to manufacturer guidelines. If the valve clearance is found to be out of specification, adjustment will be necessary to combat issues like poor engine performance or misfiring. After performing any required adjustments, if the valve clearance checks out as correct, you can progress to the following troubleshooting step. This process helps ensure that mechanical aspects of the engine are functioning correctly, contributing to the overall air-fuel ratio management. In Step 5, the focus returns to conducting another cylinder AF test with the engine running. After starting the engine, maintain the engine speed at approximately 3,000 RPM, again, ensuring that the vehicle is in park or neutral with no load during this test. Similar to the previous tests, ensure the AC is off and all other electrical loads are disconnected to maintain consistent conditions. After achieving stable engine speed, perform the cylinder AF test 3 times using the HDS in the inspection menu. An OK result would indicate an intermittent issue within the air-fuel adjustments of the system. Should the result not be satisfactory, the next logical step in troubleshooting should be pursued to identify any ongoing concerns causing air-fuel discrepancies. Step 6 involves visually inspecting the exhaust gas recirculation EGR line, focusing on potential blockages that could contribute to the air-fuel anomaly. Begin this step by ensuring the vehicle is turned off. Next, examine the EGR line for carbon deposits or sludge, which can impede proper exhaust flow and affect emission controls. Accumulation in these areas often correlates with poor performance and error codes relating to the air-fuel ratio discrepancies. Should any carbon or sludge be present, a thorough cleaning of the intake manifold EGR port and the EGR pipe should be conducted using throttle plate cleaner to eliminate the obstruction. If no carbon is found, proceed to the next diagnosing step to ensure that all potential sources of failure are methodically checked. Next, Step 7 focuses on inspecting both the intake and exhaust manifolds for carbon buildup, which can severely impact engine performance and efficiency. This step involves examining both manifolds to detect any signs of blockage or deposits that could interfere with air-fuel ratios. Should carbon buildup be identified within either manifold, this might necessitate additional checks for oil leaks present in the engine that may have contributed to the accumulation. If leaks are evident, they should be repaired, and carbon deposits should be cleaned out properly to restore normal airflow. If no signs of obstruction or leaks exist, you can proceed to the injector check as the next step in diagnosing the codes effectively. The final troubleshooting step involves inspecting the injectors by switching the injector from the affected cylinder with one from a healthy cylinder. This process helps determine whether the symptoms are indeed related to a fuel injector failure. Once you have swapped the injector, start the engine again and hold the RPM at around 3,000 without load. It's crucial to ensure that AC and other electrical loads are turned off during this test as well. Like previous steps, run the cylinder AF test 3 times through the inspection menu to assess if the injector failure has shifted with the swap. If the test highlights a failure at the cylinder from where you swap the injector, then all injectors should be replaced as a set to maintain consistent performance. If the problem persists, it could be indicative of intermittent failures, thus confirming that the system is functional at that moment, prompting additional investigations on other potential issues. Final repair verification is crucial to ensure that the issues indicated by DTC P219A and P219B have been adequately addressed. After performing the necessary repairs based on previous troubleshooting steps, confirm that the problems are resolved by retesting the vehicle under various conditions. Monitor the vehicle's performance and review the OBD system to check for any remaining or new DTCs, ensuring that none are present before closing out the job. It is also recommended to keep an eye on the vehicle's performance over time, checking for intermittent faults that may reappear. Only after comprehensive checks and monitoring procedures can you be confident that the vehicle is operating properly, free from fault codes and performance issues. Although specific preventive maintenance measures were not outlined in the provided diagnostics text, regular maintenance can significantly mitigate the risks of DTC P219A and P219B. It's advisable to routinely inspect and, if necessary, replace the AF sensors to ensure that they are functioning within their recommended parameters. Likewise, periodic cleaning of the EGR and intake manifold can prevent carbon buildup that leads to performance issues. Maintaining the fuel injectors via cleaning or replacement as needed can ensure optimal operation and prevent misfires or fuel delivery complications. Lastly, monitoring the engine's overall health, including compression checks and valve adjustments at regular service intervals, will aid in sustaining engine efficiency and minimizing the likelihood of recurrence of such error codes. In conclusion, DTC P219A and P219B signify air-fuel ratio variations within the Honda Pilot from 2016 to 2022, impacting performance, efficiency, and emissions. Understanding these codes provides a solid foundation for effective troubleshooting, ensuring each step is undertaken systematically. Monitoring the related components, such as A-factor sensors, fuel injectors, and even maintaining correct engine compression are crucial to resolving the issues effectively. Additional insights gained through OBD status checks can significantly aid diagnostics. Moreover, ongoing preventive maintenance not only enhances the vehicle's performance, but also reduces the chances of triggering these DTCs in the future. By applying these methodologies, technicians can enhance repair quality and vehicle reliability. Please like and subscribe to the channel. See you next time.